Hello everyone and welcome to my channel. In this video I'm going to show you how to integrate FreeRTOS and SystemView inside a project. For this video I'm going to use a Nucleo board with the F446RE microcontroller. This Nucleo board has a SYLink debugger attached to it, so we can make the traces with the SystemView. And in case you don't have a Nucleo board and you have a PCB with a STM32 microcontroller, then you might require a J-Link debugger. Here I have some advantages why use an RTOS. So for this lesson, we need to download the FreeRTOS package. This is found on the official website. So we need to go to the download FreeRTOS. So here we have multiple options. Either we want the long-term support or we want the latest version. For this lesson, we are going to download the latest version. Next, we need the files for the SystemView. Here you can read what SystemView can do for you. And on the download section, from here, you can download a host application. So for example, 64-bit installer for Windows, in case you are using Windows. Download the sources and download the user manual. I have them already downloaded, so let's proceed further. So here are the files that we have downloaded. The user manual, host application, SystemView sources that needs to be integrated, and the FreeRTOS. So let's unzip these two archives. From FreeRTOS sources, we will only need this FreeRTOS folder, so we can delete the other files and folders. Now we can cut this one level below. Now we have everything organized and prepared for the project. So next, you can install the host application of SystemView. So double click on it, follow the steps, and the software will be installed on your PC. Next, I'm going to create a STM32 project for my board and integrate FreeRTOS and SystemView files inside it. So let's get started. Before I begin, for future projects, I have in mind to not use the STM IDE and to use the makefiles and to create a project similar to this architecture. So in case you want to see something like this, don't forget to subscribe and give a like to the video and leave a comment if you want to see something like this. So I'm going to start a new project by clicking on this icon. Or you can find this under the file menu. And in here, I'm going to insert the number of my microcontroller. So this is my board. I'm going to click on it and press next. Next, we need to give a name. So I'm going to give FreeRTOS YouTube. Next, target language C, target binary executable, and target project type. So here we can create the STM cube project, or we can create an empty project. In case you are going with the empty project, you will not have access to CubeMX and so on. So you are going to write your project from scratch. For this video, I will go with STM32 Cube. Next, we can select the firmware. We will always keep the latest firmware and press finish. To answer the question, I will answer no. Now it will try to open the device configuration tool. So I'm going to press yes. So here is our microcontroller. We can see which pins are set. Because we are using FreeRTOS and FreeRTOS uses SysTicks, we are going to the system core, system, and for the time-based source, we will change this to another timer. For example, timer 6. We need to change this, as I said, because FreeRTOS is already using SystemTick. So it will get in conflict with the HAL drivers. Next, for the interrupts, we also need to configure some interrupts. We want interrupts to have priority and 0 sub-priority, so we are going to use the maximum setting here. For code generation, for the NVIC module, we will untick the SystemTick timer, append SV services, and SVI instruction, because we are going to use this from the port of the FreeRTOS. For clock configuration, I'm going to leave it as it is for now. Project manager. Everything seems as it should be, so I'm going to save this. Do you want to generate code? Yes. So now it will try to open the C++ perspective. So code was generated, all libraries were added. Here are the whole drivers for what we are using inside our project. We are going to create 2 folders. Let's make them source folder. So first folder name will be FreeRTOS. And the next folder name, let's leave it SystemView like this. So these are 2 folders that will be populated with the files that are required by the project. So from here, we need to see that from CC++ build, this is not ticked. So it is indeed a source file that will be taken into account inside the build. Now we will proceed to add files to this project. So first, let's add the files required for the FreeRTOS. We can go to Properties, Resource, and we can click on this icon. What this will do, it will open the location where this folder is located. So we will have this open. Next, we need to open the download folder where we have downloaded our files. So let's go to FreeRTOS, and from here we are going to copy license and source. So I press Ctrl C for copy, and here Ctrl V or right click and paste. So in the license folder we have the license. We can open this. FreeRTOS currently is released under MIT open source license. And in the source folder we have some C files, include directory, and a portable folder. From this portable folder we need to keep only the GCC, because in my case I'm using the GCC compiler. So I'm going to select this with Ctrl Shift and leave only GCC folder. Now if we are going to go inside GCC, we will find some architectures. So in my case I have a ARM M4 architecture, so I'm going to search for that. So 3-core, not for me. So here are 2 variants, either this one or this one. So I know my processor has floating point unit, so I'm going to use this CM4F. So Ctrl Shift to select the other folders and delete them permanently. Now you can keep the structure of your project like this, or you can go inside and cut these 2 files, Ctrl X for cut, and put them 2 levels below. Next, we are missing one file. So FreeRTOS has a configuration file that can be modified by the user. So we are going to go back inside our download folder in here, and inside demo we are going to search a demo for our controller. If we have luck, if not, we can create file manually or copy from another project. I'm going to open this project. So the file that I'm speaking about is this FreeRTOS config header file. Copy the file, put it under the FreeRTOS folder, and let's create here a folder. Name it config from configuration, and move the file here. If you want to see what's inside this configuration file, you can open it, and here we have some defines, and the explanation will be on this website. And here is the web page of this FreeRTOS config header file. So in here you can see each of the define and its description, what it does. Now there is one more file that we need to add for our FreeRTOS, and that file is for heap management. So we need to go back inside our download folder inside sources, inside portable, and search here for mem management. And here there are 5 types of heap management. You can read about this on their website. So this is their web page, and inside here you can read about all of these 5 types of heap management. In our case, we only need one, so I'm going to use Heap 4. And I'm going to copy this inside portable. Good. Now we can go back to our project. Click refresh. Now I'm going to modify this configuration header file. So let's see. So preemption, we want it. Idle hook, yes, we want to have a function, and we will have a sleep function to put the CPU in sleep and consume less power. Next we have system core clock. We see this is declared as extern, but I don't want to have this here, so I'm going to delete that, and I'm going to locate this system core clock. I'm going to include this. So F2 to rename, copy this, and in here I'm going to include this. Tick hook, we don't want this, so I'll not have a function for every tick. Stack overflow, for now let's keep it disabled. And malloc failed hook, let's also disable this, so we'll not create this hook. Next, we will keep this file as it is, so I'm going to save it. Now we are going to the main source file, and we will create some tasks. Before that, we need to include 2 headers. So for private include, under the user code begin, we need to include these 2 headers, so FreeRTOS.h and task.h. Now we can create the tasks. So I'm going to create a 100 millisecond task and a 200 millisecond task. So we need to create 2 handlers, and also I'm going to create the idle hook. So these 2 will be the prototype of the tasks. This one will be the idle hook prototype, and these 2 will be 2 constants. Now I'm going in the other area of user code. So here I'm going to create the definition of the tasks. So here I have the definitions for 100 millisecond and for 200 millisecond. So when this task will be called, it will keep the tick count inside this local variable. It will do some action inside this while loop. And when the action will finish, we need to delay until. So here I have put this in reversed order. So let me correct this. So we will delay until 100 milliseconds. So this task will be called every 100 milliseconds, and this one every 200 milliseconds. Now we need to go back to the main. Under user code begin area, so now I have seen that our code might look smaller on your screen, so I'm going to go to preferences, color and fonts for C++, editor, and I'm going to make this 18, so maybe it will be more clearer on your screen. So here I have created these 2 tasks using the xTaskCreate API. So this one comes from the FreeRTOS sources. After the creation of these 2 tasks, we need to start the scheduler. So this is the start of the scheduler. Now we shall compile this code, but first we need to go to project properties inside C++ build, inside settings, inside the MCU GCC compiler, and inside include paths. So here we need to add the paths for our FreeRTOS header files. So let's add it one by one. So I'm going to press on this add. Next I'm going to press on this workspace. And from our project, first header files are located under this include. So include. Next one, workspace. We have some header files inside this portable folder. And we have one inside this config, which is FreeRTOS config. Apply. Do you wish to rebuild? No. Apply and close. Let's see if we forgot something. So we have included this folder, license, just the license in text format. Sources has only C files. Portable has this port macro.h. Include has this header file. So now let's build the project. Okay, so we have one error. We have an undefined reference to this idle hook. So I have the prototype, but here I haven't created the definition of the function. So let's create it. This will be very simple. So we are going to use this macro. This will send the CPU to normal sleep by using the CMSys macro. So let's save it and let's press build again. So the build is finished. Now let's add some logic inside our task. For example, let's read the button state, and if the button was pressed, let's turn on the LED in the 200 millisecond task. So let's do it like this. We are going to create here a private variable that will contain the button status flag. Also, I'm seeing that inside this editor I'm not having the syntax color. So I liked to color my code to see which variables are global, which are locals, and so on. So for global variables, I'm going with a red color and in bold. Local variables declaration, I'm going with orange. For references, I like to have them italic and orange. Macro definition purple. Let's select one of these. For the definition, let's make it bold. For the reference, let's make it italic. You can scroll here down also to see what you are modifying. So let's go further. I'm satisfied with these options now. Also, there is one other option. So preferences. We have the formatter. So from code style formatter, here we have the profile K and R. So for Kerrigan and Ricci. I'm going to select a new style. We will clone from this K and R. And in here, I don't want to use tabs, so I'm going to go with tabs only, space only. Indentation, how many indentation before each? I'm going to keep it as 4. Braces, I want them on the next line. Function declaration, next line. blocks, next line, case statement, next line, switch statement, next line. So this is how it will look. I'm going to keep it like this. I'm going to apply, okay, apply and close. And what we have done, so if we are going to select all the text inside this file with Control A, we can go to the refactor and not refactor, to the source and correct indentation, or press Ctrl+Y. So here all the code was indented according to our formatter. Now let's continue further. So now we can see this is a global variable, so I like to see them red. I don't want to use magic numbers, so I'm going to create some macro definitions. So under private define, this will be my macro definitions. So for false, true, not pressed, and pressed. I'm going to use, by default the button is not pressed, so I'm going to use this here. Now I'm going to this 100 millisecond task, and here I'm going to write the logic for the button. So we are going to use the whole library. So if whole GPIO read pin on this port and this pin equals true, then the button is not pressed. And when we are pressing the button, we are shorting the button to the ground, and we will read the pressed state. So this will be the logic inside 100 millisecond task. Next, for the 200 millisecond task, we will check this flag. If pressed, we will use this whole library API for write pin, port, pin, and set and reset. So I'm going to press save, and I'm going to build again. So now we don't have any error. We can flash this to our board.